This podcast may contain certain forward-looking statements concerning Tri-State's plans, performance, and strategies. Actual results may differ materially because of numerous factors, and Tri-State undertakes no obligation to update these forward-looking statements. We urge you to review Tri-State's filings with the Securities and Exchange Commission for a discussion of these factors.
Those lines being well-maintained and able to carry the load that we're sending over them is like the veins in your body being able to deliver blood where it's got to go. Keeping them maintained and replacing them when needed keeps the whole system working. My name is John Swanson. My job title is Substation Technician, and I work at the Cortez Field facility in Cortez, Colorado.
Can you share a little bit about your background and how you got to Tri-State?
I have about 40 years experience in the electrical industry. I was a general foreman for Local 35 for a few years. In 2008, I went to work for the Department of the Navy as an electrician, became a high voltage work leader. Then I went from there to California, became an electrical engineering tech, and went back to Connecticut doing high voltage electrical work for the Navy, and then took a job here. I was a master electrician and able to read prints.
Are you from this area?
Marlboro is where I started out and ended up in Groton, Connecticut, near the Naval Submarine Base, and then took a job in Fort Hueneme, California, and then back to Connecticut. I spent a year in Afghanistan, and now I'm in Cortez.
Where are we headed today and why?
We are headed to the Dolores Canyon solar field in Cahone. Right next to that solar field is the Cahone Substation. We'll be testing a relay at that substation.
How many substations do we have?
In our area, between Cortez and Durango, I have 9, and I think Ryan has 11.
What's the relationship between generating sources and the substation?
It's actually 2 different entities under Tri-State's generation and transmission. So they generate the power and it goes into our substation and then goes out over the power lines to all our members.
You don't visit the solar area that often, but obviously substations are a big part of what you do. If you were just going to this substation for maintenance, what would that process look like?
Well, for the solar substation, we probably are going to do the work there. And the substation that I'm going to, I have to put in the switching in advance so that our production engineers can look over what we're doing and approve it. It has to go through operations to make sure that it's not going to affect anything else in the system. Then operations sends it to any entity such as WAPA or Empire Electric to let them know what we're doing. Once all that gets approved, I get a switching order that when I get to the substation, I'll call them up and let them know that I'm starting that work.
Can you explain what switching is?
Switching is a step-by-step program that you follow to take a piece of equipment out of service to work on it without affecting anything else. Prevent you from getting injured or turning the power off. Because if you don't do your switching correctly, you could inadvertently turn off the wrong, operate a circuit breaker and interrupt the power for some customers. This switching order has 3-way communication between the switchman and dispatch just to make sure everything goes correctly. If either side sees something wrong, we can stop that switching program and allow for corrections to be made.
I think a lot of people here think of their light switch, but there's so much that goes into it before. What kind of tasks take up most of your time?
Well, the actual maintenance on the equipment. The switching is when you take it out of service and put it back into service, and then you have to take the time to do the maintenance on it. It all depends on what maintenance you're doing. Yesterday, I did a discharge on a battery bank. The battery bank is basically the heart of the substation because when the power's out, it supplies power to everything in that substation so it can still operate. The discharge test is a 5-hour process where you hook up the test equipment and it puts a load on the batteries and it monitors the voltage in the cells of the batteries while you're doing a discharge test. Basically, you get to do paperwork as you're monitoring it. The relay test that we're doing today doesn't usually take as long if it's a maintenance test. A commission test means you have to test the relay completely, and a maintenance test just says you're doing to make sure that the different parts of the relay are functioning properly. As long as the test routine works the way it's supposed to, it probably only takes an hour or so. Now, I'm a sub tech and also part of the substation department is the heavy app techs, and the heavy app techs can actually get into a transformer, pull the bushings out of a transformer, so it can take a week to do their work.
What kind of hours do you work in your job?
I work 6 to 4:30. We're kind of flexible because most of the time we're a one-man crew as subtechs. So we'll do 410s basically.
If there is an outage, are you called in?
Yes, we are on call 24/7. Being that we're on the bargaining side, they go by an overtime list. So the person with the lowest amount of overtime in the trade that's needed for the call out will get the call out first. And then if they turn it down, they go to the next person on the list. If we have an apprentice, the apprentices have to go on every call.
Going back to outages, how do you figure out what caused the fault or the outage?
The outage or the dispatcher, when he sees the fault on the line, he will call our supervisor and he'll get an indication of what it is. If it's a transformer differential, they'll know that from the equipment that are in the substation. We have a SCADA system, and the SCADA system will send him that information as to what the fault is or the piece of equipment that it's on. It doesn't give him all the information, but it gives him quite a bit. And then he'll call our supervisor, and then our supervisor will figure out who to send out for it. Most of the call outs go to the subtechs, so we can figure out what it is, and then we can call in other crews as necessary.
What kind of critical safety procedures are part of your job?
If we're working on the yard, out in the yard on an energized piece of equipment, we have mad distances that we have to maintain and follow. We start like we will today with a safety brief. Everybody can have their input on it. If they think something else should be done, we review the switching form, make sure everything in there keeps things safe. We have a saying, if it's not grounded, it's not dead. We test all the grounding in the substation on a 10-year cycle. Falling from heights is a big thing. We always have to have harnesses and what we call pogos up on the top of the transformers that we can tie off on when we get up there. We go through all the steps in our safety brief and identify any dangers and how to mitigate those dangers as best as possible.
How is technology changing your job or making it better?
The main thing we see in technology is in the relay. The relay piece of equipment is what monitors the device. So a transmission line, 230 kV transmission line, we have devices on that line for measuring the voltage and the current. And those devices send that information into the relay, and the relay calculates if everything is normal. And if there's an abnormal event on the line, it'll determine whether or not to trip the line out of service. The newer relays with the newer technology can operate it much faster and will give us a better location that it happened on the line. So when we send the line crew out, they'll know where to go and find the fault. Also, having one relay of a microprocessor type, like a Schweitzer, can replace what we call the old black boxes, which are electrical mechanical relay. That can replace like 3 or 4 of those to do all what can be done in the one new Schweitzer.
How does your team work together alongside transmission maintenance and telecoms to keep power reliable?
I like to brag about it because our crews all work very well together. All our relays that we install have to communicate with dispatch. They do that through SCADA, and the SCADA systems come underneath the Comtex. Then if we're working and there's an issue on a line or in a substation where we need help, we can call a line crew in and they can bring their equipment in and help us replace it, repair it. We all really do work together to achieve reliability of the system and getting the lights back on when they're out in a timely manner.
Can we talk a little bit about mobile substations?
Mobile substations are one of the biggest assets we offer our members for maintaining transformers or if there's a major outage. Actually, when we're bringing it to a job, we get special permission from the Department of Transportation to move that even when they won't allow any other loads to cross those roads. They'll allow us to go through because we're a utility and we need to get the lights on for people. We can set that mobile substation, which has a transformer on it and a circuit breaker and a circuit switcher. They're what closes the power into the transformer and then sends it on to the load, and we can get power back on while we're making repairs in a member's territory. We have one coming up in May that we're just working on one of our transformers, and there's no way to backfeed the load. We put that in place of the transformer that we're working on so we can do the maintenance on it without interrupting the flow.
This is important because not a lot of people have these, right?
That's correct. Empire Electric here has one that's a specific voltage for some of their substations, but it doesn't cover all their substations. And in the past, they've had issues with it, and they have used our mobile in several instances.
Let's pretend we're at an elementary school talking to first graders. how would you describe what is a substation?
I would tell them that when the power is generated at the power plant or solar field, when it comes out of there, it goes into a substation, which changes the voltage, converts the voltage into a more usable voltage to be sent out over the power lines. Then it goes to your house, and then it's stepped down again through a transformer, and then you can use it. But it's what regulates it. It's basically an intersection of power lines and different voltages. If you're comparing it to roads, it would be a major intersection where several roads go in different directions. The highway is the transmission lines. The secondary road is distribution lines, and then your driveway is the end user.
It has to keep getting stepped down. That makes sense to me and probably eighth graders.
The reason we have higher voltage for the transmission lines is we have less voltage loss over the long distance lines. And then when we get to the distribution lines, that voltage can be stepped down. So it's more manageable for the distribution companies, your local power company, to bring to your home. And then it gets stepped down from that voltage to what you use in your home.
When power is generated, what is that voltage?
It can be anywhere from 13,000 to 25,000 to 60,000 volts. And then it goes into a transformer like Cahone Substation. It'll get stepped up to, I think, 350,000 coming out of Cahone. We can step that down to 230,000 because we have 230 coming into some of our substations. And we step it down to 115,000 to send out to our distribution members. And then they'll step it down to 24,000 or 13,000 volts for their distribution line. When it gets to your house, it's 120 to 40.
Do you have any crazy stories about different jobs or different things you've seen?
The Hesper substation always provides good stories. We had an outage on our Hesperus to Montrose line. It's a 345 line. And when I went out there, we were just looking for something that relayed and we could turn it back on. It was maybe 3 o'clock in the morning, dark. On the ground, I saw pieces of porcelain, which are from the insulators that support the buswork, which is kind of like instead of a wire, the buswork is a pipe that the current in the substation flows through. I found pieces of that porcelain on the ground. And as I looked around, it was spread out all over the place. When I looked up at the buswork, actually at one of the switches, the bus had fallen down onto another insulator, which shorted out the line and caused it to trip off. So that big line from Hesperus to Montrose was out of service. We had to get all the crews together. Ryan, my coworker, was running up to Montrose to see what was going on up there. He was able to pick up the insulators from the Montrose facility, bring them down, and we replaced it.
Why is building new transmission lines such a big deal?
Well, for one, coming from the safety standpoint, if somebody back feeds into it, it can kill alignment. It's very important for the lineman to work safe, make sure everything's grounded, and make sure all that switching that we do doesn't allow any source of power into that line while they're working on it. So it's very safety sensitive for replacing an old line or building a new line that has portions of it already energy. Then the new lines or an old line could have a steel core in it, and that steel core could get rusted. That steel core is what allows the line to be spanned for a long distance because around it is aluminum, and that can't hold that tensile strength of a long line. If that steel line is old and it breaks, the line will be separating and drop to the ground. We had that on one of the lines coming in from Nucla to Cahone. That was the longest span across a canyon using wooden poles.
You're a journey level substation technician. Is it like an hour certification or like a different testing?
If you're coming into the field with no experience, it's a 4-year program with 8 steps. A lot of our training is in-house because there really isn't a training facility out there. The heavy apps have more school options, and that's for working on the transformers and the large circuit breakers and that type of equipment, where subtechs are more really meter and relay technicians, the industry would call. There's really no real schools for that. All that training is done in-house. They do a great job of teaching you everything you need to know over a 4-year period to be able to work efficiently and safely.
What other kind of people do you work with?
Mainly, every time we check into a sub, we check in with dispatch. We have an automated system where we can just enter it in, and which lets them know what we're doing at the substation. If we're doing anything which requires a switching program for them to be notified because we're going to be sending them alarms, we call them and let them know we're starting that. Basically, it's us and dispatch when we're out doing what the subtechs do.
What kind of interest led you to your field?
I like fixing things. I went to a technical school, but I took electronics. I had too ADHD to sit at a desk all day. I worked as a carpenter, a plumber, insulating person, a framer for houses, did roofing for a while. I've done some welding, mechanic work, and I settled into electrical work. It was cleaner. It was year round. And so I went into an apprentice program for electrical work. Completed that back in Connecticut, got my journeyman license, worked for several companies, and then I just like doing electrical work. One thing led to another. My wife and I wanted to get out of Connecticut, and she actually found this job on Indeed because I was applying for government jobs.
Sounds like you've spent a lot of your life committed to this industry and keeping the lights on. What does it mean for you to be able to do it now in this cooperative setting and in a town where you live, and to be able to provide exceptional service and bring a career's worth of knowledge?
Gives me a lot of pride to be able to go out and get stuff turned back on that tripped off, and also to identify something before it becomes a problem. That's something that we really focus on as subtechs, maintaining the equipment so that it doesn't fail, and yet have the knowledge and tools that when something does fail, to go out and fix it and get the lights on in a really short period of time, or bring in our mobile or reroute the power in one way or another to get those lights back on for our members so that the end user isn't without power for a very long time.
Thanks for tuning in to Western Watts. You can find us on Spotify, Apple Podcast, YouTube, or on our website at tristate.coop/WWpod. We'll catch you next time.